Welcome to our talk, hitting the refresh button on your Spring Boot application with Stéphane.
Hi.
And I. So we're
Brian.
And we're both working on the Spring Framework team, and we're going to talk about upgrading your Spring Boot app with an existing Spring Web applications.
So you had like a very short coffee break, so we have like a lot of slides for you, just to make sure you stay awake. Lots of slides with a lot of bullet points, like, 1999
That's how you do it.
Style, yeah.
That was it.
Okay.
So we're going to start with an existing application, a Spring Boot 2.7 application. And we're going to pretend we're in a new team, and we're going to explore this new application because we need to get some work done in it. So first, we've checked out the project, and then we run the project for the first time.
Yeah, tests are working fine, so that's good. Let's go with the app.
And now, of course, we run the application, and something's wrong. We are missing something. It cannot connect to a database.
Mm-hmm.
So hopefully, our colleagues did something to let us know what we... OK, we need to run PostgreSQL, I believe. And what? OK, yeah. Like, it's a nice way to let you know, like, you're on your own. Do what you want. Do what you can. So we can try and run a PostgreSQL Docker container on our local machine and see where that takes us. So we've got our container, and then we try and restart our application. It doesn't fail this time. Maybe we can see what's going on. So we can see that our application is called Spring Gaming. It's a service status application that checks on various services for our online gaming platform. So we're going to check various components like authentication and database cluster, load balancer, and so on. And now we can see that they're all unavailable somehow. So maybe we're missing something else, or the README is missing something, maybe, to let us know that we should do something.
README. Oh.
There's a
run mux.
quite handful scripts folder where you can have this bash being run. This starts an app, and this time we'll see that some components are up and some components are down. And that's how we do it. OK.
All right.
This is our app with the components, checking the availability of components. We've got our mocks application running on the side, and we've got incidents being fetched from the database of ours.
And the tests were working, so we'll see about that, because they didn't need a database, apparently. So who's still using Spring Boot 2 at the moment?
2x. Good, all right.
OK, like 10%. Shall we upgrade, or?
Yeah. Do you want to see an upgrade? I mean, it's an easy one, that one. We don't use, this application doesn't use Hibernate, so it's Spring Data JDBC. I mean, it's not a cheap chop. We had consistent feedback from the community that some Hibernate.
It's not cheap. It's not cheap. That's
Hibernate
for sure.
upgrades were a bit challenging. So this one we're gonna upgrade. And Flyway is complaining because
Flyway is complaining because the database is too recent compared to the version we're using. So yeah, latest Spring Boot 2.7. No warning in your logs except that one. That's why I showed it to you. No deprecation in code, no deprecation in configuration properties. Reading the logs is very important. If you see warning in the logs and the application is working, that doesn't mean you need to take care of them, because once you upgrade, it may turn out a different affair. So yeah, let's go ahead and upgrade.
Yeah, for deprecations, we tend to keep them around for 2 minors at least, so you have a chance to look at them. And but after 2 minor upgrades, things might be gone at some point. So here we're gonna upgrade to 3.0.13. Is it the latest? I don't even know. Anyway, we're migrating to that one.
Yeah. Oh, we're not migrating to 3.3 straight, right? Because of what Brian said. You may get like some deprecation in 3.0, some new deprecation in 3.1, something in 3.2 that's gone. So if you miss those steps of upgrading feature release by feature release, you may end up in a situation where you go straight from nothing to it doesn't compile. Actually, that's what's going to happen, so it's funny, but for a different reason. All right. So 3.0 is like a chance for us to do major refactoring. And this is what we see here, some methods that are gone. Let's have a look to them. and they're gone because actually we could show you the
issue and
the release notes
the
and
release notes in the wiki. So yeah, the Spring Data team took the opportunity to like separate things a bit more. So the interface model is a bit more separated. So this means that paging and sorting repository doesn't implement the same methods anymore. So in this case, for us, we need to extend 2 interfaces because we want the CRUD methods as well in our methods.
Works. Okay, perfect. So I'm going to cheat a bit and just go straight to 3.3 because we know that it's going to work out fine.
Yeah, we
except
didn't have
one thing actually.
Oh,
Flyway.
Yeah, so there's been a change in Flyway. They've split it a bit the artifacts, I believe. So since we're using Postgres, now we need a specific artifact to get the Postgres support. That's the only change we have to do from 3.2 to 3.3 on our side. And now we can still run the application and it works.
Okay, yeah.
So
not all upgrades will be as fast and as easy.
Yeah. It's still a demo.
It's still a demo, right?
How realistic it is.
Okay, so let's now talk about we've upgraded, so that's nice and fine. But let's spend some time also to look at what new features you get with Spring Boot 3.3, because sometimes you do the upgrade and then you don't have time to investigate those new features, and we want to show you how we can improve this application to make it easy to use. So maybe let's start with
the JDK upgrade.
Oh, let's start with the JDK upgrade.
Before that, so 3.3 is compatible, and as well as 3. I don't remember which version. So we're compatible with JDK 21. So with that, it means that you have a new option, which is enabling virtual threads in your application. And this means with this current model, if you look at the application.properties, so if we look at the threads right now, you can see that we've got a bunch of threads. Some of them are configured for Tomcat for handling requests. Some of them are for tasks because we are running tasks for
many
checking
tasks or whatever.
Like components.
Let's pretend it's a high traffic application, right?
Yeah.
And so you need to have like
20 and 20 right now.
And we can see those here. That's for web requests, and you can see the scheduling one increasing because it's like ingesting incoming tasks, and that's why you see it increasing.
So many threads and thread pools are good to handle traffic, and you need to tweak them, but they also come with a cost, which is the size of the stack in memory, and also thread switching, which can be costly. So in this case, we want to check out the virtual threads feature and see how it goes for our application. Luckily, it's not really hard to do it. You can enable it with Spring Threads virtual enabled true. And with this, Spring Boot will configure automatically for you the web server, the task executors and pools, which are not pools anymore. So we'll use the virtual threads by default, which are really threads from a pure Java API perspective. You can still use the thread API. The only thing that changes is that instead of being real platform threads, as in real threads in your operating system, they are being pulled, and they're green threads, like very lightweight threads, that are mapped at runtime to actual operating system threads. So you can have a bunch, like millions of those, and you're still relying on a specific reduced size of platform threads. And that's what we get right now. As you can see, we don't have those thread pools anymore, and we have the platform threads in the fortune pool being used instead.
And it's a sweet spot if you have like an application that does a lot of I/O. So if you're really CPU bound, that might not give you much, because those threads will be in use anyway. But if you have a lot of I/O, then you end up with those platform threads. They used to actually do nothing, because they're waiting for some response from a remote service. Enabling virtual threads lets you use those platform threads more efficiently. As you can see, it's a single option. It's not something that we can do. Spring Boot, like, see, you're running on Java 21, and hey, let's enable virtual threads because it's a conscious choice. You need to look at your application, see if it's actually a good fit, and there's some caveats too. So
So the upsides that you can expect is lower memory consumption because you won't be using as much memory with threads. The other one is you might have better throughput depending on the profile of the runtime profile of your application. So if you're waiting a lot on IOs, reading and writing to HTTP connections or whatnot, this might be fruitful for your runtime profile. But as Stéphane said, it's not like a given. You need to really check it with performance tests or even in some QA environments against real traffic, because sometimes we got feedback from the community saying, oh, I've discovered a new bottleneck in my application, because before you were somehow limiting the traffic of your application through the thread pool of your web server, so limiting the amount of traffic you could handle. And now with virtual threads, you can handle as much as you want. So you need either to limit that somehow in another way with the max connections or something, or you'll find out maybe that the thread, some kind of connection pool down the line to your database or something else is limiting the amount of traffic you can handle. So that's a good thing to really test your application with that option because you need to find out what's the new runtime profile of your app.
Right, okay, so let's talk a bit about our tests and the fact that they work without the Postgres database. How come?
Yeah.
So let's see. Okay, so we have a data JPA test here. Doesn't do anything funky, so let's have a look to the dependencies. Oh, right, okay. So we have H2, so basically that means that when you run your test, they use H2. Maybe we've configured that with the PostgreSQL compatibility mode, but it's still not the real database, so we would like to fix that.
Yeah, you probably run into that problem, I did, where you have a different dialect maybe between H2 and whatever database you're using, or a bit of different profile, or it's not the same SQL like statements that you need to use. And also you might run into problems in production that you didn't have in your test because they're not the same support exactly. So with this, you can use instead the real database, the real stuff, and we can use the real PostgreSQL database and the real version that we'll use in production to test our integration tests in our application.
So who knows about test containers? Yeah, quite a lot of you.
Yeah.
It's great.
2/3. So we'll use the test containers annotation, and we'll obviously disable our test if we don't have Docker or something that can run containers locally. And we will replace our existing database source, and we'll use the container.
Yeah, so that's the test containers API. Essentially, we've added like 2 dependencies. We've added the JUnit. Let's go back to that. Added the JUnit integration, and test containers has this notion of for everything it integrates with, there is a module with a similar name. So you can see here the PostgreSQL module, which will bring the PostgreSQL support. So this is really test containers and kicking off the downloading of the image, running the image before your test, etc. Then you still need to tell Spring Boot, hey, by the way, the database is here, because the container will start on a random port by default, because you don't want it to use the default port of Postgres. You may have a Postgres database running on your machine. So this code is actually doing the heavy lifting of telling Spring Boot, hey, by the way, there is a database, here is the URI, the username, and the password. Okay, so let's have a look if it works.
Okay, with that, we can run our test against the real database, the real stuff, and we're more confident about deploying the application to production because we won't run into like very nitty-gritty problems with the database.
Okay, so, oh, it's still complaining about H2. It's funny, even though it's not using. It is using it. What did I do?
Did you refresh the build.gradle thing?
It should work, because it should work, right? What the hell? Blah 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 blah. Why?
Or the app is still running, the main app. Maybe it's.
Oh, that's because I can't speak English. That's why.
All right.
Okay, there we go. And it's still working, so that's a good news. Yep.
All right, this time we're using the real database. All right.
So we told you about Spring Boot 3 upgrade and the nice goodies and whatnot. We're not supposed to tell you this, but actually you can write this code with Spring Boot 2 if you want to, right? But let's pretend you can't. You have to upgrade. But we will see how we can improve it like shortly. Right. So we still need the database. Let me actually shut that down so that it's clear it's not running. Run the test again. Yeah, it still works. That's great.
But
Okay,
we still need to have our local database to run the application locally, right?
Yeah, it's so painful. Okay, so can we fix that?
So we'd like to improve the onboarding. So we already did with the tests. We had some runtime improvements in production with the virtual threads. And now we want to basically remove that dreaded README file or the wiki page, that internal wiki page that's never up to date in your company. Instead, you can use Docker Compose. With this, you can write all the services and explain how they should look like. And a lot of you already do. And you just run Docker Compose on the side and run your application. But this time, we can integrate that directly into your development lifecycle within your application.
Yeah, so that you actually don't have to do this effort of, okay, first knowing that there is a Docker Compose file. If you're new to this, know how to start it. Docker Compose up -d is not too complex, right? But you still need to figure that out. So how can we really integrate that with the development lifecycle? And so there's an integration in Spring Boot 3 where it will actually go ahead and see if there is a Docker Compose file in your project, and it will start the container automatically if they haven't started yet. So it will figure out if there's something to do, and when you stop the application, it will also stop the containers for you.
There are a lot of options with this. You can have multiple services, you can add labels, you can share them between applications, and so on. You can have a policy about when they should be started or shut down, and so on. So you can really have your opinion in there.
Right. So,
but the thing is, how come we have that development only dependency and it works? Like, we didn't have to remap all those properties from, oh, that's the container to that's the real properties, and we had to do this in our tests.
Yeah, it's frustrating, right? So we should do something about it. So what would happen if instead of Spring Boot Docker Compose, I would write Spring Boot Testcontainers?
So with this dependency test implementation this time, we can improve the support of test containers in our test and remove the plumbing, the boilerplate that we have right now, with that concept of service connection.
And you need Spring Boot 3 for that. So you have to upgrade for sure. So service connection, this is like a new API that when it's placed on a component, there is an API, and you can also implement that API. So we do support connection for most containers that Spring Boot has auto-configuration with. So database, backend services like Redis, Elasticsearch, whatever. If you happen to have like one in your own company, based on your own conventions, you can implement this API and register it in a file, the same way callbacks work, the Spring Factory file, and then we will call you. And you'll have a chance to say, hey, I can actually manage that object and do the necessary to update the environment. So with that, you don't need to care about those properties, and it's basically taken care of for you. It's very nice.
So to summarize, we had runtime improvements, better onboarding with tests, and running the application locally. But we still don't have much on the API side. Like, we would like to get some improvements, for example, with the client.
Yeah,
that we're using?
we actually skipped the demo.
Yeah,
I
think we
realize that
skipped
now.
So right now, our application, as we said earlier, it's checking for external components by issuing HTTP requests and checking whether they are live or not. So this is a test that we have that does this, that tests this behavior. They're expecting a response for that component, which is the authentication service or like the matching service, whatnot. And we're using mock MVC to test that. And that's it. So do you want to improve the client?
Let's have a look to the client. Who's using the REST template in the room? Yeah.
Quite a lot of people.
Who has seen like the maintenance mode notice in the documentation? I can see someone nodding and being very angry. I can see. So yeah, that was quite a thing, right?
That was awkward. Yeah. I mean, it's not in maintenance as in we're gonna shut it down. It's in maintenance as in we're not gonna evolve the API because it's complete at this point. So we're still maintaining it. We're not gonna retire it. And as a result, we created RestClient, which is the functional reactive variant of it, because we wanted to work on the new use cases that people wanted, which is streaming and scatter gather and so on. But we got a lot of requests from the community about, yeah, we'd like that nice Fluent API, but we don't really want to opt in reactive because we're not into it. And so we got that message, and we've been working on RestClient, which is just that, using the same infrastructure as REST template, so the same request factories, the same HTTP libraries support, but with a different API where you get a Fluent version. So here, as you can see, sometimes REST template can be a bit painful, where you have to create an entity. If you want to send headers, you need to create an entity, create the headers, and send all that, and so on. Here, we can fluently get with a new URI that we're providing, and providing headers inline, like the accept header, so we're accepting JSON, and we're also sending an authorization header and copy pasting all that. And instead of having multiple like overloaded methods on the same class REST template, because this is a Fluent API, you can fluently choose your path. So here we've chosen to get an entity out of it, and that's basically the same call, but with a different API, more pleasant. And we didn't change much because, as you can see, we're still using the REST template builder. So we're getting the REST template configuration that we have in our application, and we're building a REST client out of it. So it's easier for you to start migrating. You can, bit by bit, component by component, say, okay, this in here, I want to use the REST client. I'm going to get the configuration from my app, and then start using REST client from here. And you can gradually migrate to the new API if you want to in your application bit by bit.
And if you really want to put REST template out of the picture, you also want to configure the client with the Fluent API, you can do so, and Spring Boot will help you. So it will also auto-wire a REST client builder. So with the builder, you'll get the new API, and that's pretty much it. And did I wrote that wrong again?
What? Oh no, it's two related problems in the tests, maybe?
Oh. Wow, what's happening with me? I'm like blind or something. I thought it was a compilation error.
Not enough coffee.
Yeah, yeah. Okay, so let's fix those so that we can move on and run the test to make sure we didn't break anything.
All right. Other than that, we're supporting the same types of clients, including the new JDK client, and also the usual like HTTP components and others.
Okay. All right. So let's switch to SSL maybe?
Yeah, SSL. So that's an interesting feature as well for runtime. So if you're running your application in production with TLS certificates configured with your app, sometimes you need to rotate them, those certificates. It doesn't do it automatically. But here we've got a new feature, new features in Spring Boot for this, which are, the first one is SSL bundle. So SSL bundle is a way to configure multiple sets of SSL configurations in your app. and they're named. So here we're naming example.org because that's our main domain, let's say. But you can have multiple bundles and configure different sets of private keys, certificates, and various options. And here we're pointing our server, our web server, to the example.org bundle. So pointing to the private key, the public key, and also we're asking our bundle to be reloaded automatically if those certificates change at runtime. So it's checking from time to time whether the certificates changed, and that's what we're going to show. So here we're
not going to show you the browser because it's going to scream at us like we shouldn't be doing that. So it's not very
because they're
helpful.
self-signed anyway. So here we've got one certificate. So we basically did a curl request getting the certificate out of the current version of our server. It's still running. We're not changing anything.
And we also have a script to update it.
So
that's done, and you can see that
in a few seconds,
if you have good eyes, it's like, it should be blue, right? Stéphane is not in the right directory, that's why.
So you can see, in the logs, we already had the connector from Tomcat being reloaded with the new certificates. What it means at runtime is that all the existing connections won't be shut down with the previous certificates. All the new connections, though, will be using the new certificates that we have in our app. So this time, new connection, different certificates. So that's a nice way to, one, configure your multiple TLS certificates or configurations in your app with bundles. And two, you can point them in different parts of your app, your server, or other support that needs TLS. And you can use that to reload them automatically.
All right, so the next demo, there is a bit more change. So given how awake I am, I'm not going to code that. But we want to talk to you about the improvement in observability and in Spring Boot 3 and the fact that we've overhauled the feature. So by the way, we will share the project with you, so if you want to give it a try yourself, you'll be able to. So this commit actually brings quite a bit of new services. So we have like Prometheus for scrapping metrics, which is running against our application. We have Grafana, if we want to show those metrics. And we also have Zipkin to send traces to it, distributed traces.
Cool. So if you were using Spring Cloud Sleuth with Spring Boot 2x, this is a new way of doing things. New as in way better, because Spring Cloud Sleuth was instrumenting all the Spring libraries, so that was a lot of work for one project. And also the way to instrument Spring libraries it was not always possible or well, like in a nice way. So as of Spring Framework 6 and Spring Boot 3, Spring projects are now instrumented directly by the teams, and we're using the lightweight observation API from Micrometer. So it's a very slim and light dependency. If you don't have Micrometer on the class path, it won't do anything, and it won't be a performance overhead for your application. But if you do have Micrometer and like a collector for metrics or traces, you'll get all of that directly.
You've noticed also that the log format has changed. So we detect that you're using this, and where you see that blank space, that's for the trace IDs. So you basically get the context directly in your logs this way. If you parse the logs to in a system that's able to ingest them. Well, also to show you like this schedule task, you see nothing really specific about it. It's like running every 5 seconds and using the client that we've upgraded, so it's using RestClient to contact the mock server we've started initially to check what's going on. And with only that, then you get those traces automatically.
So as a Spring Boot 3, you have the instrumentation for web client, web server, a bunch of things. And as of Spring Boot 3.2, we're also having this in our traces. So you can show, we've got HTTP GET for actuators and so on. And here, we also have traces and metrics for tasks. So we have our schedule task, and as you can see, we've got the code function, which is the name of the method. We know which class is it, We know if an exception happened, and then you can see the inner spans, which are all the HTTP GET requests we made with RestClient. So you have a clear picture of what's happening within a scheduled task, the entire thing, and then each individual call if there's instrumentation going on. And here, interesting fact, we can see that there's one error, and that this is a failing server, and that, oh boy, it's taking 2 seconds. So maybe we can make like the timeout shorter, or maybe we have to think about it. That's a nice way to see what's going on, even in places where it's really hard to look, besides adding log statements or trying to do instrumenting yourself. Here, the instrumentation is done for you, and it's all integrated with metrics and traces.
And not new, but okay, if I can type again. Is it 3000? I think so, yeah.
Oh, with Grafana.
Yeah, let's have a look to that quickly.
So we even have dashboards for Spring Boot.
Yeah, we do. Let's do that. Okay.
All right.
I need
Importing the dashboard.
Database, data source, sorry. Yeah. Then you get those nice nice graphs. So Grafana, if you don't know that, they have like this notion of public dashboard. You can publish a dashboard, get an ID, and then you can import that into your local installation. But those metrics are exported automatically. So as you can see, there is not a lot of config to make that happen. Just like a few dependencies that you need to add. Let's have a look to them. So we're using Prometheus. As you know, Micrometer can export to various systems. So we've chosen Prometheus. So we use the registry. We exporting to Zipkin using Brave. So those are the two dependencies that we need to do that. And in terms of configuration, there is not much actually. Let's have a look to that. It's really, actually, it's even like not necessary. We ask to trace every request because usually it will trace like 10% or something like that. But when you do a demo, you don't want to wait for the right thing to actually be traced. So that's why it's like
10 times.
Yeah, and we also have like shorter export just to make sure that the data is available automatically. But essentially, those two you can get rid of them. And I can't remember why we did that, but that's really not necessary. I mean, for the demo.
Yeah, for the demo, yeah.
Let's move on.
Yeah, so now we have better observations. Next step is, shall we do the startup time again? Or we had it in the keynote, maybe? Do you want to see, like, or do you want to?
Do you want to see it like short, slow pace rather than rushing?
Not rushing.
The CDS demo that we had. You want to see that again? Yes. All
okay.
Right.
So we'll explain more. We're a bit behind the schedule during the keynote, so we've tried to.
I mean,
some people tried to rush things.
Some people were behind schedule.
So yeah, as we said during the keynote, we've advertised a lot the Java -jar option because it's easy and so on. But for quite some time in our reference docs, we pointed to efficient deployments for Spring Boot apps. And Java -jar has a cost for startup time because it's got to like look stuff into nested jars. It also has a cost at runtime. So if you're serving static resources, it's way less efficient than serving with an exploded version. And the build packs have been exploding the jars for since their inception, I believe. So it's really the way to go. So if you want better startups in production, you really should look into exploding it. Is just one CLI command away. You can use the tools which are available where you can extract things. We've introduced them a while ago when we introduced as well the layered containers, so where you can build your own Docker container with layered images, extracting things in different layers in your Docker container. And here, that's what you can do. You can extract. You have various options for extractions. And here, we're going to extract locally into a non-existing destination. Yeah. That one doesn't exist. So we've expanded the jar in this location, and you'll see we've got libs, all our dependencies, and a main jar, which is really
It's your code essentially, and a manifest that contains the class path. So that's very important. It was something that we didn't have really a chance to address during the keynote. Is the way CDS works? It's really picky about how the JVM is started, right? So if you start, for instance, the JVM with a list of jar files, and you do the training run, and then you start it again, but you modify the order of the files, the cache won't work. It will not work as efficiently. So we want it really for you to have that out of the way, because that's something that you can do it wrong like very quickly. Something that doesn't work either is if you use libstar. So if you have like a directory with jar files and you say, okay, just create a class path with all the files in that directory, that won't work. And if you use a directory with classes, so if you have like exploded your classes to look for resources or whatever, that won't work either.
Yeah.
So you really need to work with jar files, and you need to work with a list that's consistent. The order needs to be consistent, and you also need to do that with the same JVM. So you may wonder what happens if you don't qualify for those requirements, and that's where it's really nice, from my opinion, is you'll just not get the benefit, or not as much benefit, but your application will work just fine. So if the cache is invalidated, it will work transparently. It will load the class from the jar file where it would be if CDS was in use. So it's not like you have a broken setup and things break. It actually won't. It will not be as fast as it would be if it's done properly. So the training run, it's actually something that you need to do once, and you need to repeat it every time the application changes. But once you have an application, a deployment unit, you can run the application as much as you like using the same cache. So we have like 3 flags. There's actually one that's not, I wouldn't call that not standard, but it's specific to our application. So let's go back to the spring.context.refresh, spring.context.exit, sorry. So this is really a lifecycle flag that Framework has implemented to support Crack and CDS to be able to start the app, but in a way that it won't start servicing requests, but it will be as close as possible to it. So the intent is to load as many classes as possible compared to a regular startup time, so that the cache is filled with as many classes. So that's the first one. The one on the left is the JVM standard flag. It's just like telling, hey, please dump the cache once you exit. Oh, I forgot to say also that the exit on refresh, what it does, it will actually actually end the application when it's reached that state, so that you don't have to do that yourself. So you can see the application is starting. Whoops. The application is starting. It ends immediately, and then CDS take over and start dumping the cache. Finally, the last flag is to make sure that we don't start like connecting to remote services. So this is something that's not really done in a standard way in Spring Boot, because there's so many different options, and you may also have your own services and your own code. So it's not like a free lunch again. If you have like things that do like crazy remote HTTP on startup in the bean initialization, I'm not talking about like events and stuff like that, but if you in post-construct, if you're like doing weird HTTP calls, don't do that. That will happen. So you'll have to move your code to, for instance, listening to an event, which will not be fired when the training run is in progress.
Other than that, this needs to happen as late as possible in the life cycle of your application deployment. So it should never happen locally on your laptop, because it probably won't be, even if it's Java 21 on both, if it's not exactly the same JVM, chances are the format of the class archive won't be the same, and it'll be thrown out. So this is why doing this in a container, if you're deploying containers, or on the server where it's going to run, is important, because if you don't do things right, it's easy to not get the benefits.
Yeah, and that's where like Paketo build packs it really shine, because it does all those things automatically for you. It will apply those best practices, so we highly recommend you to give that a try. it's in your build. It's like you enable a couple of options and you're good to go. We didn't talk about AOT. Actually, it's not there because I don't have the same code as the other demo. But if you remember from the keynote, it's like two key really. One is really saying I want to use CDS and it will do all the heavy lifting for you, and the other one was to disable flyaway. So basically passing properties to the options to the training run. Something also to mention for AOT is it's also very easy to get that wrong. So for instance, you may process your application ahead of time and then forget to actually enable that flag when you do the training run. So the training run will not operate on the same environment as the actual run. So buildpack will take care of that for you as well. It's just an extra property and you're good to go.
Right. Shall we do 1.6.2 feature maybe? The exception handling?
Sure, yeah.
So we've shown already a bit of the mock MVC tester new integration with Spring Framework 6.2, which is in milestone phase. So you'll get it with Spring Boot next November. But it's still time to test it. You can override that version in your existing Spring Boot app as long as it's 3.3 plus, and you can check it out and try things out and give us feedback. We'd love to.
Okay, so we have, before we do that, we decided like 5 minutes before the talk to do this, so it may not work. We have an exception. So if you with the API you try to get some incident doesn't work, you get this. So this is something that you can do with like regular Spring Boot 2, Spring Boot 3, whatever. But something that we've added in Spring Boot 3 is the support for an RFC called problem details. So why don't you give it a short thing while I'm trying to remember how to code this?
All right. So problem details support has been introduced in Spring Framework 6.1, I believe. And this is a nice standard way of returning errors from your application from REST APIs, where you have, like, it's very close actually to the heritage format that we have in Spring Boot, like the errors page that we have. It's adding a few additional fields, including like titles. You can have a link to an actual page that describes the type of issue. You can have localized messages in Spring where you have like message properties per language and so on. So it's a very nice way to very step up with your error handling game in your API. And here we've got an error response exception, so we're extending a base class from Spring Framework that gives you a lot of this for free, that will turn that exception into a problem detail at runtime when you get that exception handled into your controller. So at the Spring Boot level, we need to enable problem detail support in our application properties, and because this is an exception that extends that base type, if you, without having any exception handler whatsoever, if you hit the endpoint that will trigger that error, you should see the error response. Like, okay, so this, for example, this one, where we're getting a title, the type, which is about blank by default, but you can have an error type, which is supposed to be a URI to a stable URI to the description of the type of problems. And then you can have a localized message. You have the application problem JSON content type. So it's pretty much all standard codified, and you can reuse that all over your applications for your REST APIs.
But that's not what you wanted to show, right? You wanted to show something else that's 6.2 specific, so let's do that.
So yeah, so what people like a lot about Spring Boot error handling is that you can have several like types of media types. So if it's an HTTP or curl client, CLI client, you'll get the JSON. If it's a browser, you'll get a nice HTML page. And you can vary the type of error message depending on what the client is asking. Here, what we'll do is we'll keep the existing one, like with the problem details, but when it's a browser, instead of having like JSON being sent to our clients, we'd like to have an error view. So we added an...
I'm going to show you first, yes.
So that's what you'll get in your browser. Instead, we'd like to have an exception handler. you can always have exception handlers. It's been there for a while. For that, you need to have the exception in the method signature, or you can have it in the annotation if you want. And then returning model view says, I'm going to render a view, and that's what I want. But here we've introduced a new attribute on that annotation, which is produces. And with this, you can actually opt in and select which media types you want this error handling to be involved with. So here we want to target only text HTML. So we want to have still the same problem details for regular REST clients, and we want to have a nice error message, error view with text HTML if the browsers are asking for it. So here in this case,
doesn't work.
Doesn't work.
What did I do?
Exception handler producing.
Something had to fail. The last demo is always the one. Okay,
Should
maybe
I have a look at what we did last time?
That's what happens when you have like last-minute plans. Oh, but maybe I screwed up actually. Do I have the template here?
Translation the URL. If you go back to the browser.
Yes.
The double slash, does this make a difference?
Oh, the double slash?
No.
Probably not. It's all
It did actually.
It was?
That's
Okay.
really strange.
It was a 4.4 before?
Yeah.
Okay. Okay, that was it. I don't know why. So this time we're getting an error view, and we're getting we can actually get the exception with all the information as a model in our view rendering, and we can do basically what we want with our. This is handlebars, right? Handlebars view, where you can get the data and render whatever you want in HTML as an error.
All right. So I guess our time is up, I think.
All right. Yeah, I think so too.
So if you had questions and you put them in the app, we'll look at it ASAP. We're still around. Obviously,
you can grab us in the hallway.
Yep, not leaving this awesome conference.
And you can check out the demo app.
Yes, the demo app, yes.
Which is conveniently in a repo. It's right there. And you can have commit by commit information with all the steps that we showed today with comments and everything. So you can check it out and retry that at home.
Oh, and we've been asked also to tell you to go there, the Tenzu booth.
Okay, yeah.
So there is a number of events that's going to happen at the conference. Don't miss that.
Yeah, and we'll be hanging out there as well. So
yep. So we hope you'll enjoy the conference.
Yeah.
We hope you'll enjoy the conference. Thank you very much for attending.